In several examples here and on WebAssign, we've dealt with drag forces. So let's talk a little bit about a drag force. If I have an object that's falling, and let's say it has reached terminal velocity, that means it won't fall any faster. So that would mean that our velocity is constant, therefore we have no acceleration. In that case, there's something that must be balancing this gravitational force. And the thing that's balancing it is air resistance. In this case, we call it the drag force. If we've reached this terminal velocity, these two forces must be equal. So that means Fg equals F drag, or Fg minus F drag equals 0. And then you have to be careful about your signs, because I've already put the negative in front of F drag, implying that I've considered the force of gravity to be in the positive direction here. Okay, well, what can I do with this? Well, let's assign some numbers and see. So let's say that block up there has a mass of 3.6 kilograms, and it has a terminal velocity of 36 meters per second. I haven't told you what the drag force looks like yet. The equation looks something like this: negative b, or just some coefficient, times the terminal velocity, or velocity. In this case, it's going to be the terminal velocity. So our drag force would be some coefficient times our velocity, not necessarily our terminal velocity, just our velocity, to some power. That's a lot of like, it's something times something to something. So let's assign a couple numbers. We're going to say we know that exponent there is 2.5. And what we want to know is, what is that drag coefficient b? Okay, so we can just use this equation here. And I have already taken care of the negative signs over here when I wrote out that the forces must be equal. So what this means is the magnitude of the gravitational force must equal the magnitude of the drag force. So if you think about that, this absolute value can mean that I throw out this negative. Right, so now we have Fg equals F drag. Just to be precise, their amounts must be the same. We already know that they're pointing in opposite directions. Right, so b to the n equals mg. Just go ahead and write v to the n equals mg. And I want to know b, so b equals mg over v to the n, which is 36 newtons over 3.6 meters per second times 2.5, or sorry, to the 2.5. And then if we work that out, we get that b is about 0.0046.